Hello friends, today we are going to learn the numerical of mechatronics based on the LVDT. First of all, I will read out the numerical. I will zoom it. Numerical is an LVDT has an output of 6 volts when the displacement is 0.4 into 10 to minus 3 mm. Then we have to find out the sensitivity of the instruments in voltage per minute mm. Sorry. And next subpart of the numerical is if 10 volts voltmeter with 100 scale division is used to read the output, 2/10 of the division can be estimated with this. Then we have to again find out 2 points, that is nothing but resolution in of voltmeter, and next point resolution of the voltmeter in centimeter. This is nothing but we have to find the resolution in voltage and here resolution in centimeters. Now first of all we know what is LVDT. LVDT is long form of LVDT, linear voltage differential transfer or linear voltage differential transducer. Now here there is one linear scale and that is moving, and based on the movement of the linear scale the voltage is get changed. And here again this LVDT is connected to the voltmeter and we have to find out the resolution of that voltmeter. First of all we will find out sensitivity of the instrument. Sensitivity is nothing but, in simple way, if you want to see, sensitivity is nothing but output upon input. Now what is the output here? Now as we know, the LVDT is giving us the voltage and we are supplying change in displacement to the LVDT. Hence this will be the output of the LVDT and this is nothing but input. Hence directly if sensitivity is asked, you have to find out this ratio upon this thing. Even though if they don't give you this term, then also the sensitivity will be the ratio of voltage per mm. But here they have made the problem very simple so that you should not do any mistake. Hence by looking at this also, this is nothing but output and this is nothing but input. Hence directly put the values in the output 6 volts and in input 0.4 10 to minus 3 mm. Then what will be the answer? We will just see. Sensitivity, its symbol is S, and this is the formula in some broader way, and this is the numericals we have put, numerical terms, and this ratio will be 15,000 volts per mm. Okay. Now next point, what they have asked. The second point they have asked, the resolution in voltmeter. Now resolution means how much minimum value the voltmeter can measure. Now see, the voltmeter ranges from 0 to 10 volts and there are 100 scale divisions on the voltmeter. For this you will see one image of the voltmeter so that you will get understand what is the voltmeter. Now see, this is the voltmeter. It is varying from 0 to 30 volts. For example, I have given, and here how many divisions are there in the voltmeter? See, 1 2 3 4 5 6 7 8 9 10. Means in between 0 to 10 there are 10 divisions. Hence from 0 to 30 again there will be the 30 divisions. Hence for 30 volts there are 30 divisions. Hence each division corresponds to 1 volt. Hence the 1 voltage will be the least count of this equivalent. Now if suppose LVDT is connected to the voltmeter and for each division again the scale is there on LVDT, and that scale can divide this division, then again the least count will be the reduced. Now see, I will explain that in more clear way. Now this is the point that I already explained, what division correspond to 1 volt here. But in the problem what is given? It is varying. In the problem the voltmeter is varying from 0 to 10 volts only in this, and the with 100 scale divisions, mean here from here to here, instead of here there are 10 divisions were there, but in our numerical from here to here there is 100 divisions, means one division will be equal to, giving the voltage is equal to 10 divided by 100, that is equal to 0.1 volt. Suppose this is that voltmeter, and the least count of this voltmeter will be 0.1 volt. 10 by 100 means 0.1 volts. Okay. Now again, this is the resolution of voltmeter in voltage. You can see this is the resolution of the voltmeter in voltage, or least count of the voltmeter in voltage. Now see, what is the LVDT? See, this is the LVDT is there. This is the scale on the LVDT. Now what is the mention in the problem? I will just read the scale. Now what is mentioned in the problem? 2/10 of the division can be estimated. Now see here, that already I have shown you the voltmeter. This is one division. This is nothing but one division. One division correspond to 0.1 volt, and 2/10 of this division can be again found out. 2/10 means what? 1/5. Means 1/5 of the division can also be found out. How that is found out? See, here are here scale can read 1/5 of the division. Now see, this is the scale. Okay. Now this scale can, what they have told, this scale can measure 1/5 of the division. Okay. Means here again the least count is being reduced here. Okay. Hence for finding the least count of the LVDT, what we have to do, again we have to divide that least count by 5, or multiply it by 1/5 of the division. Why? Because the scale can read 1/5 of the division. Directly they have mentioned here. Means what? Again we are reducing the least count. Previously there was 0.1 volt, and one division correspond to 0.1 volt, but for one division we have used LVDT to reduce the least count, and hence the final least count will be 0.02 voltage. This is the resolution in volts, but we have to find out in the last point the resolution in centimeter. How can we find out? For that we will again go to the first part, that is sensitivity. Now we know that sensitivity we have got 15,000 volts per mm, means 1 mm is giving you 15,000 volts. 1 mm is giving 15,000 volts. That is the sensitivity. Now what is that? How to, by using that sensitivity value, we have to find out the resolution in mm. How can we find out? That is very simple. See here, this is the resolution in voltage, 0.02 volt, that now we have found out. This resolution in voltage, if you divide by sensitivity, what is, why sensitivity? Because it is in volt per mm. Now this is in voltage, this is in volts per mm, and the final answer you have getting, that is nothing but in mm only. That is resolution in mm. Means you have to divide this by 15,000, you will get the final answer, that is 1.33 into 10 to the minus 3 mm. Okay, in this way we are getting the resolution in meters or centimeters. In this way we have completed this numerical. Again in future we are going to see such kind of numerical. Thank you very much.